comfort the beautiful poem. Now let's get into our environmental corner with Sarah.
Thank you. I'm doing very well. So today we will be seeing the potential link between allergens and pollen with climate.
Correct. We got several data by two scientists on the increasing rate of carbon dioxide and the temperature effect on allergy plants.
Allergic plants are the plants that create allergy, and allergy means that a damaging immune response by the body to a substance like the pollen for particular food or dust to which your body has become hypersensitive. And if you don't know what hypersensitive means, it means you have to go look at a dictionary. Okay, so the potential links between the climate change and the allergens depends upon the environment, elevation, and carbon dioxide, in this case, the
Thank you,
greenhouse
Sarah.
gases. Okay, so let's look at this graph. As you can see, the data shows the change in amount of airborne in Europe, which compares the rate of 1969 and 2003. If you look more closer, which you cannot, but I can. Well, you might can, but yeah, the pollen rates varies by the country. However, what is this making this change?
Now
The countries represents the inward temperature of the environment, and the pole represents the indirect proportion between them. For example, let's look at a Switzerland average elevation. Well, it's not average, but it's the highest peak. As as we know that CO2 mostly located close to the ground because it's heavy. It won't be much in Switzerland because they have high elevation, so the CO2 won't be living there. And the Switzerland's elevation is 4,634 meters, which is 25 times higher than DFW. Because CO2 and amount of airborne pollen have direct proportion, higher the elevation, lower the amount of
Okay,
pollen.
so we're facing some technical difficulties.
As for United Kingdom, their highest peak is at 979 meters, which is at Scafell Peak. The pollen grains increased 4.7 times on the O and birch because UK is lower elevation than Switzerland. The CO2 reaches UK and increased the amount of pollen for over 4.8 times. Take a look at this physical map of Europe. Watch this graph and compare Switzerland and United Kingdom. Most of UK's elevation is low, while Switzerland is on the Alps mountain, which raises its elevation.
Okay, Sarah, I think that is it.
Now take a look at this second graph. In this graph, the seasons show the temperature, while the duration of the pollen seasons are shown next to it. Of course, the winter's duration is shorter because the pollination happens the most in warm time, not cold.
Sarah, I beg.
This is another example of fact about the link between climate and pollination season, and in this case, the change in the lasting time of the season.
Okay, now the pollination time has lengthened for the summer and autumn. For every season, most of them are just getting long, except the winter time because pollination happens when the environment is warm, not cold.
Now, let's compare these two data. If we do some math with finding the correlation between these two, the environmental chamber in the future will have 1.7 times more pollen than the current level, which is 103 ELISA. Elisa? When we use another math, we could say that in 50 years the carbon dioxide level will be raised from 370 to 703 pmol per mol. This will bring the pollen higher, like we said
Now
before.
let's check out our next table, and by the way, it's not a real table.
This is more direct data from the last one. For example, the concentration of pollen in birch trees at 270 meters above the sea is 103 ELISA. But the unit gets higher when the elevation drops and the temperature rises and turns to 130 ELISA Only 1 through 2.5 degrees can be the difference between 130 Elisa and 103 Elisa. Look at this graph of the CO2 level. The level gradually increases since the if I can talk today, industrialization. Thus, the pollen increases
Now,
too.
let's look at our last table, and it's not a real dining table. Yeah.
Now that because of global warming, the pollen season time is getting earlier from 1969. And yes, the result is dependent on CO2 and elevation. For instance, France has very high elevation of 4,810 meters, but it's still the highest peak. And it varies, so they have low amounts of allergens. Just one disclaimer that the elevation vary and elevation that we're giving right now is the highest peak.
Thank you,
It's not
Sarah.
the
I
average.
think that is enough. Now, I think I need to talk, and you need to stop.
So now you know the links between climate and allergies.
Now, okay,
Thank you. I hate the allergy seasons. Okay, where were we? Oh yes. Okay, where were we? Oh yeah. So the potential links between the climate change and the allergies are the elevation, environment, and carbon dioxide. But there are more too. The light from the sun reaches the atmosphere, but to get through the atmosphere, it requires energy. So, but because the light has lots of energy, it gets passed through it. Some of them get reflected, some of them get absorbed by the object. Now, because the CO2 is increasing, it traps the heat. Where does the heat come from? The object. The objects absorb the light and it turns into heat. And the heat doesn't have much energy as light, so it gets trapped.
Okay, you know what?
Thank you.
I'm done here.